we are going to look at how do you solve trig equations. It's essentially what we're going to be dealing with. And the first thing we're going to say is that when you do trig equations, unlike most equations, there's actually an infinite number of answers. So it's kind of difficult to write infinity number of answers. So we have to figure out a way in which we can express that. And that's where we're going to go right now. Well, it starts off relatively simple. If you want to solve an equation, one of the most common techniques that you use is the one I call, as long as you do it to both sides, it's okay rule. So I am going to add 1 to both sides. And then I am going to divide both sides by 2. And we're going to solve these questions because we're told to in radians. And if we were told to solve them in degrees, we would do it in degrees. Now, if you wanted to find out what size angle x is, I guess you could do inverse sine. Let's show you why that is not going to work for this question, because we want the exact value. So I'm going to make sure I'm in radians, which I now am. And I'm going to do the inverse sine of 1/2. And you see that you just get a weird decimal. So what we're going to have to do instead is we're going to have to use our unit circle. And so I am looking for, I wish that wasn't called x, but we're looking for an angle, right? So isn't that, we're looking for a place where the y coordinate is equal to 1/2. You agree? Okay. On the unit circle, in radians, where do you find places that have a y coordinate of 1/2? Well, would you agree at pi upon 6? See it? Y coordinate of 1/2. So one of our answers is pi upon 6. But there is another place, isn't there? What other angle also has a y coordinate of 1/2? Where's the other place with a y coordinate of 1/2?
5 or 6.
Yeah. Now, I said at the start of this that there's an infinite number of answers, and you might be thinking, well, where are the rest? Because there's only 2 in the unit circle. And you're right, there are only 2 in a unit circle. But you know, if you add 2 pi to an angle, don't you basically get to the same place? So this is correct, but wouldn't pi upon 6 plus 2 pi, wouldn't that also work? Right? When you get back to the same guy. And couldn't you do pi upon 6 plus 4 pi? And couldn't you do pi upon 6 plus 6 pi?
Would it be,
in fact, can you do that forever? Question.
Would it just be pi upon 6 plus 2 pi x, right?
Very close. We just don't use the letter x, but apart from that, bang on. So how do you write down all of these answers? You call it pi upon 6 plus 2k pi. And we use the letter k. And k is basically any number, 0, 1, 2, whatever. Technically, plus or minus. So far, so good. So that guy represents all the answers that are him. And this guy, well, if you took this fella and you added 2 pi, wouldn't you get a whole load of answers just like him? So wouldn't the second answer be 5, 6 pi plus 2k pi? And I think in WebAssign, the 2 answers, this one's called the small value, and this one is called something like the large value. So small value, large value, right? There's 2 answers. Well, not 2 answers, 2 infinite answers, right? They go on forever. So far, so good. That is the simplest one you're going to see. They are going to get progressively, quite quickly, uglier and more complex. So the next one I'm going to do is just a minor change, but minor is enough to cause problems. Is similar to question 1. It's going to be the sine of x plus 1 equals 0. And I'm going to do the sine of x equals -1. And that becomes, aren't I looking for, what should I call it? I'm looking for an angle x. And what is a sine? Well, I'm looking for a y coordinate of -1. What angle has a y coordinate of -1?
3 pi over 2.
Right? Since we're sticking to radians. In fact, isn't that the only one in the unit circle? Aren't there a few places where there's only one answer rather than the typical 2? Now, that is one correct answer. But if I add 2 pi to it, don't I get another answer that would also work? And if I added 4 pi, 6 pi, 8 pi, and 10 pi, you see where this is going? We are going to do that, the original value, plus 2k pi. In this case, because there's only one answer, there'll be a box that says something like small value. And I would put that guy in this box. And then there's going to be another one called large value. And in this case, there is none. Would you agree that that generates all the answers? Whereas the one that we did earlier, which is much more typical, aren't there 2 distinct answers that generate the results? So this one would be the small one that you'd put in, and this one would be the larger one. Any questions so far? I'm trying to take this as slow as I can. Are we good? Let's move up the food chain then. And told you it didn't take long for them to get weird. The next one is 4 sine squared x take away 1 equals 0. So the first thing I am going to have to do is I'm going to have to solve for sine x, right? As long as you do it to both sides, it's okay, Ro. So help me out here. What could I do to both sides to get closer to what sine x is equal to?
Add 1, divide by 4, and then square root the whole thing.
You did it. You nailed it. Add 1 to both sides. As I say, I'm doing this as slow as I can make myself. And something rather annoying happens. When you take the square root of both sides, what do you have to be careful about?
Make it plus or minus.
Yeah. So what we're looking for is a sine x plus or minus a half. So I'm going to have to separate this into 2 distinct situations. So let's go looking at sine x equals a half. And then we're going to go looking for sine x equals negative a half, right? Because both of those work. Right, in this case, I'm looking for the angle x. And so that's a y coordinate of a half. And there's going to be 2 answers for that. Again, I hate x. I wish that was theta. But anyway, y coordinate of a half. Isn't that pi upon 6? And the other guy, because we did this not that long ago, is 5, 6 pi. Now, on this guy, couldn't you add 2 pi, add 4 pi, add 6 pi, and do all that good stuff? So can't we just cut to the chase and say 2k pi? You've got that little 2k pi thing going on again, right? Now, what about this one here? Well, one of the solutions is 6 pi, but couldn't you add 2 pi, add 4 pi, add 2 million pi, and you get this guy. Now we go over here and solve when is the sine of an angle equal to -1/2. We are looking for a y coordinate of -1/2. And a y coordinate of -1/2 is, in this case, what's that? 7/6 pi. And the other place would be 11/6 pi. And in both of those, can I also add the 2 pi chi thing? Have you noticed that there's a kind of theme right now where when you get an answer, you just add 2 pi k to it? Have you noticed that? Now that theme's not going to last forever, but as long as this says sine x equals, you will be adding 2 pi k. If this says cosine equals, you'll also be adding 2 pi k. And a little hiccup, when you are doing the answers in WebAssign, they ask you to do them in the order smallest to biggest. So you could write the right answers in, but you put them in the wrong order. It's probably going to come back and tell you that you're wrong. So I'm looking at this guy and I'm saying number 1, number 2, number 3, and number 4. Does that make sense to you? That would be the order that you type them in. So when you've got 2 solutions or 4 solutions, maybe even 6 solutions, you're probably going to write them down from the smallest one to the biggest. Any questions? Are you still with me? Okay, that's a good sign. I like that. Let's move up the food chain. Secant x 2 cosine x plus 1 equals 0. So we've got 2 things multiplied together equaling 0, and we need to solve. Well, that's going to be a bit of a problem, but let's go for it. When something is factored, then either this is equal to 0 or this is equal to 0, right? If 2 things multiplied, call that A, maybe call this B. A times B equals 0 can only happen if one of them or both of them are 0. Let's take this one out because he's a red herring. The secant of x equals 0. You might be thinking, I don't know when the secant of x equals 0. If I rewrite it as 1 over cosine x equals 0, I don't know if that helps any, but that's impossible. If you draw the secant function, doesn't it look like that? It never actually equals 0. So that means no solutions, right? Nothing coming from there. You can ignore it, essentially. On this side, I'm going to take 1 away from both sides. And then I'm going to divide both sides by 2. And since this is a cosine, right, the angle x, I'm going to call it angle x, just to distinguish it, is going to be the x coordinate in our unit circle. Right, that's why I don't like x. I wish that was there. Right, so I'm looking for a place whose x coordinate is -1/2. And one of the answers I get is 2/3 pi. Where is the other place in the unit circle whose x coordinate is -1/2? Where is the other place in the unit circle which has an x coordinate of -1/2. What angle is that? It's over here somewhere. You see it? 4/3 pi, right? An x coordinate of -1/2. So we are looking at 4/3 pi. And once you got an answer that came from this type of question, you could add 2 pi, 4 pi, 2 million pi. So we do that guy. And the same thing here. Once you've found one of your answers, you could then add 2, 4, 6 pi to it and get an infinite number of other answers. I'm hoping things are going good. I'm not getting too much feedback because I can't see too many people's faces. Do you want me to take any one of those earlier 4 questions and go over any part of it, or are you okay? Okay, got nods. I can do that. Every time, as I said, they get worse. They're nice in a way. They're challenges. I like challenges. This is a version of question 5. 2 cosine x plus the square root of 3 times 2 sine x take away 1 is going to equal 0. A times B equals 0. That means either the first, excuse me, the first thing is equal to 0, or the second thing is equal to 0. All right, let's start with this one. If you subtract the square root of 3 from both sides, you get that. And if you divide by 2, you get that. And I am looking for, right, angle x. And it's going to be any guy that has an x coordinate of -√3/2. So this angle here has an x coordinate of -√2. So that is 5/6 pi. And the other one is down here somewhere, and that is 7/6 pi. And we can now add on any multiple of 2 pi that you like, and that's one solution. And any multiple of 2 on that section. So far, so good. I'm going to have to stop for a second. Okay, I'm good. Next fella, this one. Well, if you add 1 to both sides, and then you divide both sides by 2, you're trying to find an angle whose sine is 1/2. That means that angle x has a y coordinate of 1/2. So I'm looking for places that have a y coordinate of 1/2. Well, pi upon 6 does. And the other possibility is a y coordinate of 1/2 is this guy, who is 5/6 pi. And then if we just add on multiples of 2 pi. Here are our 4 answers. Now, the smallest one of this list. Oh, that is interesting. Did you notice something about those 4 solutions that I've just noticed right now? Look at these 4 solutions. What is unique or interesting about them?
2 of them are the same.
Right. Would you agree it would be pointless to write the same answer twice, right? So I'm going to kill that one. I'm not going to write it down. So there are 4 boxes in WebAssign, smallest to biggest. And what I'm going to do is put the smallest one, which is him, the next one, which is him, the next one is him. And in that last box, I'm just going to put in none. So that's how you're going to cope with the fact that you may have 4 solutions, but 2 of them are the same. Could you imagine you might get a situation where 3 of them are the same? Right? When you have 2 lots of none, there'll be 4 boxes, because the way WebAssign does it is it randomizes the questions. So George does it and he has 4 different answers, and Mary does it and she only has 2 that are different. And so that's kind of how they're working that out. So when you're doing your answers, there are going to be 4 of them. That's where 1 goes, that's where 2 goes, that's where 3 goes. And in the last one, it's none. Now, in a different world, can you imagine that was a different angle, right? Then you'd have 4 different answers in the 4 boxes. So kind of dwelling on that, because you could do the right answer, but you just don't write it in the way WebAssign wants you to do it, because sometimes it can be kind of pernickety. Let's move on to question 6. I have a tan of x. I have a sine of x. I have a take away sine of x, and I have an equal 0. First time we've seen this situation, although it's kind of similar to question 6, but not, you know, a lot like it, but it's similar. Any suggestions for what we could do algebraically to get this closer to solving? So if a tan x times a sine x, take away a sine x equals 0.
You divide both sides by sine x.
I hear this divide by sine x, and I can understand why you would want to do that, but I also thought I heard, I think I did, that you could pull out sine x as a common factor. Now you might say, what's wrong with dividing both sides by sine x? Because you end up with that, which is really good. But do you know what you lose? You lose all the solutions that you get from sine x. So in these questions, don't divide both sides by sines, cosines, or tangents, right? It tends to destroy answers. Now that means we now have the sine of x could be 0, or the tan of x take away 1 could be 0. So far, so good. Now, this guy, 0 is an answer. You agree? Isn't pi an answer? Isn't 2 pi an answer? Isn't 3 pi an answer? So I'm not going to do the usual 0 plus 2 pi k and pi plus 2 pi k. Couldn't I just do k times pi? Would you agree that gives you every possible answer for this thing? So sometimes you have to adjust depending on the circumstances. Now this fella here is going to give me tan x equals 1. And if you're doing a tangent, aren't you looking, it's kind of hard to say it in English, but aren't you looking for an angle whose y coordinate divided by its x coordinate is equal to 1, right?
So would that be pi over 4 and 5 pi over 4?
So let's check it. Pi upon 4, correct. And 5/4 pi, correct. Now, the reason that we normally have 4 boxes, but this question only has 2 is, well, we've already discovered, doesn't this take care of all of these permutations? So all I need to do is write down x equals k pi for that one. Now over here, I've got this guy and I've got this guy. If I add 2 pi to this, well, actually, yeah, add 2 pi to this. And if I add 2 pi to this guy, you will get pi upon 4 plus pi, pi upon 4 plus 2 pi, pi upon 4 plus 3 pi, and pi upon 4 plus 4 pi. And you may say, well, where did that one come from? If you rewrite this guy as a pi upon 4 plus pi, can you see that when you add the multiples of 2 pi, you really just get this sequence? So we're kind of combining 2 patterns into one. And the patterns are pi upon 4, and you only need to add a k pi. And so that would be your 2 solutions. So you'll look at question 6 and you'll only see 2 boxes, even although it superficially looked like there should be 4 of them, right? But when you add 2 pi to all of these guys, and you add up 2 pi to all of these guys, what you discover is that there's a simpler pattern that generates both answers using the same pattern, right? So in this case, if you just keep adding pi to pi upon 4, so you add 2 pi, 3 pi, 4 pi, you'll get all of these answers. And in this one, if you do pi, 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 you get those answers too. So that's a little thing that never happened before. Keep asking, because I keep hoping things are still going good. Are you still with me? Have you noticed that you don't get a lot of practice on any particular kind, because this is, you know, there's almost an infinite number of equations. So you have to take each one as it comes, which is why I'm going one at a time. So the next fella is 2 cos squared x. Take away a cosine x. Take away a 1 equals 0. Anybody who can tell me what to do next deserves brownie points. This is not obvious at all. But this guy can be factored. How on earth can you factor 2 cos squareds, take away a cosine, take away 1, and yet you can? Go for it. No matter if you're wrong. I mean, just have a bash at it. What do you think it might be? If it helps you, how about 2b squared, take away b, take away 1 equals 0? I know it's not quite the same, but algebraically it's very close.
Is it 2 cosine minus 1 in the first bracket, and then cosine plus 1 or something? I don't.
You're darn close. Only one thing I want you to change.
Has to be negative so that when the 2 cosines multiply together.
Yeah, there it is. You see it? Now, if you don't believe me, FOIL that thing out and it ends up being this guy. So that's the first time that we ever got a quadratic equation in the form of a trig. If you factor that out, wouldn't you get 2b plus 1b minus 1? Wouldn't you get that? Now let's see what happens next. Well, if you take this guy, then 2 cosine x plus 1 has to equal 0. subtracting 1 from both sides, and then dividing by 2. So we are looking for angles. So an angle X that has an X coordinate of -1/2. And X coordinate of -1/2 happens at 2/3 pi. And it also happens an X coordinate of -1/2 at 4/3 pi. Now, in this case, you can't really merge those guys easily. So you're going to get that guy plus the standard 2k pi. If you do this one, you're going to get 4/3 pi plus the standard 2k pi. And I can tell that because there's 4 boxes on the answer, so I know nothing's going to combine. Now we've got this fella over here. And he ends up being that guy. And so we're trying to find an angle X that has the property that its X coordinate is equal to 1.
Isn't that just 0?
It is. So in this case, won't your answer be, technically you would be saying 0 plus 2k pi, but can you understand why nobody would write the 0, right? And that ends up being the answer that goes here. And then the 4th box, I now understand, just gets filled in with none. And I have made not a mistake in the math. Everything that I've said is correct. But I have made a mistake in the order that you write them down. In WebAssign, you do smallest to biggest. Which one of these 3 is actually the smallest and should have went on top?
2k pi.
Because technically, isn't it 0 plus 2k pi, right? And then you make this 2 and 3. Now, I'm making the assumption that if you typed it in the order that I've written here, WebAssign might say you're wrong and you're all confused because you're pretty sure you did it right. I hope that it is generous, and even if you don't put them in order, it kind of knows what you meant and still gives you the points. Has anybody got this in front of them that they might want to check it out? No? Well, if you come across it, tell us tomorrow and say, yeah, I put it in the wrong way around, but it was okay. Or, nope, I put one of them in the wrong way around and I had to fix it. And that way we can share that with everyone next time.
Will the none box always go last in website?
I would guarantee that, I would think. The none box always goes last.
Okay.
Okay. So I want to show you excuse me. Another one that's already been factored. And this one isn't like any of the questions. I just made it up. I guess it's similar to 7, but not much. It's already factored. So the reason I'm choosing this one is to show you a situation that we haven't come across yet, but probably will happen to you because of the way WebAssign randomly picks numbers. And it's because of this guy here. If you try and solve that, aren't you looking for what angle gives you a cosine of -3/2? Is there any angle in the unit circle whose x coordinate is -1.5, -3/2?
No.
Right. So that means there is no solution. Remember I think it was the secant one. Remember the secant one had to be 0, and that also gave you a no solution. So isn't it possible that sometimes one or both pieces might have no solutions to them, right? In which case none would go in the box. This one here, of course, does have a solution. And oops, I did two things at once. So I am looking for an angle x as a y coordinate equal to a half. And I've done that one tons of times by now. It's pi upon 6, and the other one is over here, 5, 6 pi. And don't we just add the 2k pi, because those two guys can't be merged together. So there's one of your answers, there's the other. And I just noticed something. When you are writing your answers into WebAssign, the x equals is already there. You only put in that piece. So technically speaking, I shouldn't be writing that x equals, should I? Because in WebAssign, it's already down here, right? And I do know that it will tell you you're wrong if you put in the x in the box. I mean, it's a trivial thing, but it's software isn't, what's the word I'm looking for? Software isn't always sensible, right? It doesn't always give you answers that it should or work the way it should. This question is the last one where we'll be able to use the unit circle for a while. There are a couple of questions that are going to come later that involve us doing using calculators and doing all sorts of other things, right? So let's get this guy underway. We're not looking for the cosine of x or the sine of x. We're trying to solve for the cosine of 2x. First time you've seen that. Going to approach it in a similar way. So far, so good. Now, technically speaking, aren't we looking for an angle called 2x that has the property that its x coordinate is a half? You agree? An angle 2x whose x coordinate, because it's a cosine, is a half. And so we're looking for 2x. And when is the x coordinate going to be a half? It's going to be at pi upon 3. And the other place where the x coordinate is a half is down here somewhere, and that's at 5/3 pi. Now things are going to get a little bit messier than you expect. At this point here, you would probably want to do this, and it makes perfect sense why you would want to do it, but don't. You would think, well, I need to know what x is, so I'll divide both sides by 2. I need to know what x is, so I'll divide both sides by 2. And that will be 2 of my solutions. And then I'll just figure out who the rest are. And you might suspect that you just do the 2k pi thing, right? That seems perfectly reasonable, doesn't it, as a logical progression based on all the other ones? Yeah, I said, don't do it. Okay, why not? When you get to this line, add in your 2k pi. Now divide everybody by 2. Do you see the difference between this solution and what you would have got if you'd done it the other order? Do you notice that it's plus a k pi, not plus a 2k pi? Do you see that? And the kind of the reason behind this is, right, if that's the answer, won't adding 2 pi get you another answer, and adding another 2 pi, get an answer. So it's at this point here that you introduce all the other versions of 2 pi that you could add on. And then you solve for x after the event. So you take care of the 2 pi part first, and then you divide by 2. You don't divide by 2 and then add in the 2k pi, right? So it's just something you've got to be aware of. Are you okay with that little hiccup? And that's how you deal with it, right?
Can we do another one of those?
Oh God, yes. Oh, by the way, there's 2 more answers. I haven't even finished. There are 2 more answers, technically. These take care of all the answers, right? If you take this version, you have to add in and let's see if I can get the other one. You have to add in those 2 as well. Now, where in heck are these 2 guys coming from? Well, if I go over here, which is actually a better answer, if you add 1 pi, do you see you get 7 6 pi? And if you add 1 pi, you get 11 6 pi. So do you see that this fella here gives you all your answers? And in this one here, if you want to go this pathway, don't you have to figure out who those 2 are? Would you agree that's just more efficient? Prettier? And would you agree this one is a little bit uglier because you get your 2 answers, but then you have to figure out who the 2 other ones are, and they're not obvious.
So you just got the second set of answers by adding a pi to pi over 6 and 5 over 6 pi?
Yeah.
Okay.
And you might think, why pi and not any other number, right?
Mhm.
That would be the period of this function is pi. And so whatever the period is, you add it on.
Okay.
That's why I prefer doing it this way. I mean, you don't need to go hunting for them. Isn't this going to have all the answers? These 2.
Mhm.
And so I suggest strongly that you go that road. And hopefully WebAssign agrees with me. And if they don't, tell me and I'll give you the points anyway. So let's do another one of those guys. I'm trying to figure one out that's going to come out reasonably nice. Let's do let's introduce 3x, right? And take away root 3 equals 0. If you add the square root of 3 to both sides, you get that. If you then divide both sides by 2, you get that. And so I am going to be looking for an angle called 3x that has the property that its y coordinate is equal to root 3 upon 2, right? And when I look at my unit circle, the places that have a y coordinate of root 3 upon 2 are pi upon 3. And the other one that has a y coordinate of root 3 upon 2 is 2/3 pi. Are you happy about so far? Right? Nothing too different's happened. Right, now we have the problem. I suggest that you go this route. Add the 2 4 6 pi here. And now you can divide by 3. And now you can divide by 3.
Would that be pi over 9?
9. Yeah, it would be. Divide by 3. And that is you finished. Now, if you did it the way WebAssign looks like they're doing it, wouldn't you get these two answers and then you would add multiples of 2 pi k, and then wouldn't you have to go hunting for all the other ones, right? And if you were going to do it that way, what is the period of the sine of 3x? What is the period of the sine of 3x? Anybody? The period of the sine of 3x.
Is it 2/3 pi?
Do you recognize where the 2/3 pi is coming from there? Of course, if you're going to do it that, you know, the other way, won't you have to write 6 answers, each of them with plus 2 pi k? Whereas if you do it my way, you can just get 2 answers that generate them all. So this is more efficient. Right. Next fella is using calculators. And this is a little bit different, so I won't need a unit circle because I'm using calculators. And I'm trying to solve 2 sine x equals 9 cosine x. And we want to get all the answers, right? So we're still going to do that plus pi k or 2 pi k thing. But before I can get there, don't we have to figure out how to solve this equation? And it's the first time we've ever seen a sine and cosine looking like that. And so you might be wondering how you do it. Well, what I'm going to do is I'm going to, in this case, break my own rule of dividing by things. And I'm going to divide both sides by cosine x. And that is going to give me 2 times the sine of x over the cosine of x equals the number 9. Okay, any suggestions what the next line is going to look like then?
Would you change the 2 sine x over cosine x into 2 tangent?
I would. And what would we do next? Say again, please. What do we do to both sides?
Divide by 2.
Okay. Now, that is definitely not in the unit circle, but we know that because they went and said, give me the answer. What on earth did they say? Give the answers to. They said, give the answers to. Well, that's their fault. They should have said, give the answer to 5 decimal places, but they never bothered to, so that's fine. I'm going to go here and I'm going to find the angle x. And to do it on the calculator, you use the inverse tan. So the inverse tangent. Oh, I am in radians. Let's just make sure. Yeah, I am. Okay. So inverse tan of 9/2, and I get the answer 1.3521. Now, there's always going to be 2 answers, right? If you're looking for this particular guy, all sine, tan, cos, one of the answers is here. And it happens to have, in radians, that guy. That's the first quadrant.
So since it's a tangent, would you just add pi to it?
Ah, good. Well done. Yes. It's over here in the third quadrant. Wouldn't you just add pi to it? Which makes tans very easy, because if you take this one and you add pi to it, and then you add 2 pi to that, and you add 2 pi to that, can't you get the whole answer by just doing a single k pi? And that's what the answer would be. And if you used your calculator to write down 2 of those numbers, which you certainly could, I'm now going to go into Desmos and show you how Desmos can be used to do that same kind of calculation. So if you kind of hang in there with me for a few more moments. I'm going to type in, what was it, tan x? So I'm going to call it y equals tan x. And I want it to be equal to 9/2. And now I'm going to go here. Right. And can you see that one of the answers was here? Can you see that 1.352 that I talked about? And the other one is if you add pi to it. Can you trust me that that's what you get if you add pi? And if you added another pi, you would get that one. If you added another pi, you would get that one. So you can actually let Desmos get you the 2 answers. Do you see that there's your first answer and there's your second answer? And if you write it the way that they're doing, it would be this angle, 1.352 plus 2k pi, and then they would do 4.494 plus 2k pi. But I think it's much easier to just take this one and add pi k. So that's the one I would choose. Any questions? I think you've done really well to hang in with what was a lot of different flavors and tricks and situations, right? I don't think we got to do more than 2 of any particular type. So I'm now going to talk to you about question 10 and make your life very easy, because use these given equations, right, to answer the following questions. And so f of x is the sine of 2x, so I'm typing that one in. This is essentially question 10. And the second equation is, eventually it's going to be 2 sine, oops, 2x, add 1. And if I go here and I do a graph of it, they show you 4 pictures and you draw it. Now, we would like to know where this guy is equal to that guy. Is that the sine of 2x? Let me double check that. I want to make sure I've got the right question. Okay, I believe it is the sine of 2x, and it is. Okay, I was right after all. Right, are you still looking at Desmos here? Now, if I zoom in a little bit, one of the 4 pictures is going to look like that. That's question A. And then it says, find their points of intersection on the range 0 to 2 pi. So if you're only interested in finding out when the blue thing is the same value as the other one, and you're interested in it from 0 to 2 pi, I could simply just go over here and do the little curly bracket, 0 less than or equal to x, less than or equal to 2, type in the letters 2 pi and do that. and make sure it's curly brackets. Do that. There we go. And if I go to this one, I should be able to just copy the same stuff, put that there. Have no idea where these brackets came from, but they're going to have to leave the building. There we go. Can you now see that all you're looking at is the two graphs in the range 0 to 2 pi? This one's coming out dead easy. Would you agree that they intersect at that point there? Oh, and it's in radians. Isn't that nice of them? And at that one. So there's your only two answers. And you write down their coordinates and you are done. Now, I wish we had time to finish off, but tomorrow I'll do question 11, and that's us done the first section.